Hello students, how are you all? I am Gurmeet Singh and welcome to CREATA Classes and also welcome to our lecture on area of triangle. This is the coordinate geometry series and the link to all other lectures is given in the description. And also do not forget to download the PDF of the concept and formula list. The link is given in the description. Check it out. So without taking any further time, let's start the lecture. Here it is. In the previous lectures on the area of the triangle, we have covered various formulas of the area of the triangle, which includes area of the triangle is equal to half into base into height. And we have also covered the Heron's formula. And we have also seen the formula of area of the triangle using the angle theta. Okay, that is by using the trigonometry. So basically we have covered several formulas of the area of the triangle. And in this coordinate system also, we are covering one additional formula, that is we will find the area of the triangle when the coordinates of the triangle are given. That is the vertices of the triangle are given. So basically, if we are having a triangle with the vertex as A, B and C, here the coordinates of the A, B and C are x1, y1, x2, y2 and x3, y3 respectively. We know the coordinates of the vertex of this triangle. So how we will find the area of the triangle? One method is that by the distance formula, first of all we will calculate the sides of this triangle. Once we got all the sides of this triangle, then we can apply the Heron's formula to find the area of this triangle. Okay, this is the straight strategy that we can use. The other method is that we will discuss in this lecture. So let's begin with our lecture, that is we will find the formula of the area of the triangle in the coordinate system. So let's proceed. First of all, let's draw the perpendicular line from the vertex A, B and C toward the x-axis. These three lines are perpendicular to the x-axis. Okay. Let's give the name of these points as Q, P and R. Further, are you able to observe various trapeziums in this figure? These are the three trapezium that we are able to observe in this figure. The first trapezium is ABQP, the second trapezium is APRC, and the third trapezium is BQRC. These are the three trapezium. So based on these three trapezium, can we find the area of this triangle geometrically? Can we do so? Let's try. Can we say area of this triangle is equal to addition of these two trapezium and minus area of this trapezium? That is, area of triangle ABC is equal to area of trapezium ABQP plus area of trapezium APRC minus area of trapezium BQRC. Okay. So basically we have subtracted area of these two trapezium from our this trapezium. By doing so, we can get the area of the triangle ABC. Okay, are you able to visualize this equation? We will get the area of our triangle ABC. So basically the fundamental is that for calculating the area of the triangle, we have to calculate the area of the trapeziums. And we have already done the formula of area of the trapezium, which is equal to half into the sum of the parallel sides into the distance between them. This is the formula that we have covered in the area and the perimeter. Okay. So can we say area of the trapezium ABQP, that is this trapezium, is equal to half into BQ plus AP into QP. Here BQ and AP are the two parallel sides and QP is the distance between them. So this is the formula of the area of the trapezium ABQP. Here if you observe, here BQ is Y2 and AP is Y1, and can we write QP as x1 minus x2? Okay, this complete length is x1 and this is x2. So can we write QP is equal to x1 minus x2? Okay, the same fundamental that we have used in our previous lectures we have used. With the help of the coordinate of the point on x-axis and y-axis, we have got this equation. So we got area of trapezium ABQP is equal to half into y2 plus y1 into x1 minus x2. Moving further to our next trapezium, that is APRC. What will be the area of this trapezium? The area will be equal to half into AP plus CR into PR. Here AP and CR are these two parallel sides and PR is the distance between these two parallel sides. Here we can write AP as y1 and CR as y3 and PR, that is this distance, as x3 minus x1. The same fundamental we have used. So we got the area of this trapezium as half into y1 plus y3 into x3 minus x1. Okay. Moving further to our next trapezium, that is BQRC. Here the formula of this trapezium will be equal to half into BQ plus CR, that is these two parallel sides, into QR, which will be equal to half into y2 plus y3 into x3 minus x2. So basically we got the area of all these three trapezium. Now we can find the area of the triangle, which will be equal to addition of these two trapezium minus area of this trapezium. We know area of all of these trapeziums. Let's put the area in our main equation. On putting the values and solving, we got area of our triangle ABC is equal to half into x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. This is the formula of the area of the triangle. First of all, don't be afraid by looking at the length of the formula. Okay, we will try to observe this formula and we will try to extract some retaining technique. So first of all, we will observe the formula. The area of the triangle, we know it is equal to half into base into height. So half, it is common in the main area of the triangle and area of the triangle in the coordinate form. Further, if you observe, here x1, x2 and x3 are in a systematical order. That is in a sequential order, x1, x2 and x3. Further, in the brackets only y coordinates are coming. And if you observe these subscripts, that is 1, 2, 3, they are also in a cyclic order. That is 1, 2, 3. And in the second term, it is 2, 3, 1. Basically 2, 3, 1 are in a cyclic order. Okay, 1, 2, 3, 1, 2, 3. So 2, 3, 1 is in a cyclic order. Similarly, 3, 1, 2 in the third term is also in the cyclic manner. So a small remembering technique. So if it is helpful, you can remember this formula. Otherwise, you are always open to generate your own technique to remember the formula. So moving further, we got the area of the triangle in the coordinate form. So we have done with the theory. Let's take down NCERT example questions. The example questions from question number 11 to question number 15. So the first question is, find the area of a triangle whose vertices are 1, minus 1, minus 4, 6 and minus 3, minus 5. Try to solve this question by pausing this video. Okay, very simple question. So coming back, in this question, the three vertices of a triangle are given. We can take these three vertices as x1, y1, x2, y2 and x3, y3. And in this question, we have to calculate the area of this triangle. So all the values of the variable are given. So we can directly apply our formula of area of the triangle, which will be equal to half into x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay, let's put the value and let's solve it. We got area of the triangle as 24 square units. So this is the answer of the question. Very basic question, just to show you the implementation of the formula. Okay, let's move further to the next question. The question is, find the area of the triangle formed by the points A 5, 2, B 4, 7 and C 7, minus 4. Pause the video and try to solve this question. In this question also, the three coordinates are given, okay, and these three coordinates are the vertices of a triangle ABC. And we have to again find the area of the triangle. Again, all the variables are given, so we can directly put the value of these variables into our equation, that is the area of the triangle. On putting the value and solving, we got our answer, that is area of the triangle as -2. Oh, 1 minute, our answer, that is area of the triangle, is coming in negative. But it is not possible that the area of the triangle will be in negative, it should be in positive. The area of the triangle should be in the positive, it cannot be in the negative. So we will take the numerical value of -2, that is 2. So we got the area of the triangle as 2 square units. Okay. So the fundamental that we have learned from this question is that the area of the triangle cannot be negative. And if we got any of the answer which involves the area of the triangle in negative term, then we will take the numerical value, that is we will take only the positive value. So we got our answer as 2 square units. And we also got a small understanding from this question. Okay, got it? Let's move to our next question. Slightly a tricky question. The question is, find the area of the triangle formed by the points P -1.5, 3, Q 6, -2 and R -3, 4. Pause the video and try to solve this question. Okay, coming back to the question. Again, in this question, the three vertices of the triangle PQR is given. We know all the three coordinates. We can directly apply the formula of the area of the triangle. Okay, let's do so. Let's put the value and we will solve the question. On solving, we got area of the triangle as 0. What? We got the area of the triangle as 0? Is it possible? Is it possible to have the area of the triangle as 0? What we should do, in the previous question we got the area of the triangle in negative. There we have taken only the numerical value. Okay, here what we will do? Here the area is 0. It is acceptable. The case is that all the 3 points, that is P, Q and R, are collinear point. Means all these 3 points are coming in a straight line. If any of the 3 points are coming on a straight line, then the triangle cannot be formed. Only a straight line will be formed. Okay. So we got that area of this triangle is 0, which means that the point P, Q and R are collinear points. So we got one more understanding from this question, that is, if we got area of the triangle as 0, means the points are collinear. Okay. Then also we will again check with the coordinate systems whether these 3 points are collinear or not. Let's take our coordinate system. Let's draw the point P. The x coordinate is -1.5 and y coordinate is 3. This is point P. Similarly, we will draw the point Q, that is 6, -2. Similarly, our point R, that is -3, 4. Let's try to join all these 3 points. We got the point P, Q and R are coming on a straight line, that is these points are collinear points. Just a small verification technique to prove that these 3 points are collinear and area of the triangle formed by joining these 3 points will be 0. Okay. Let's move to next question, example number 14. Find the value of k if the points A 2, 3, B 4, k and C 6, -3 are collinear. Let's observe the question. In this question, we have to find the value of k. 3 points are given, point A, point B and point C. All these 3 points are collinear. All the 3 points are collinear means all these 3 points are coming on a straight line. Further, point B is given as 4, k and we have to find the value of k. Basically, we have to find the value of the B coordinate. Got it? So how we will proceed with this question? Here, if you observe, the 3 points are collinear. 3 points are collinear, it means that no triangle will be formed by these 3 points. If the 3 points are not in a straight line, that is non-collinear, then only triangle is possible. If the 3 points are in a straight line, that is collinear, then no triangle will be formed. Here these 3 points are collinear, it means no triangle will be formed, or we can say the area of the triangle formed by these 3 points will be 0. Got the point? No triangle is formed, it means that area of the triangle formed will be 0, which is equivalent to no triangle formed. So this is the approach that we will use. We know all the 3 points, that is x1 y1, x2 y2, x3 y3. Let's use the formula of area of triangle. Let's put the value. So this is the area of the triangle, and the area of the triangle is equal to 0. Let's equate this with 0. On solving for k, we got k as 0. It means that the coordinate of point B is 4, k, which is 4, 0. So that is the answer of this question. So let's move to the next question. If A minus 5, 7, B minus 4, minus 5, C minus 1, minus 6, and D 4, 5 are the vertices of a quadrilateral, find the area of the quadrilateral ABCD. Pause the video and try to solve this question. Okay, coming back to the question. Here in this question, the 4 points are given, which are given as the vertices of a quadrilateral. ABCD is a quadrilateral, and we have to calculate the area of this quadrilateral. Let's observe the quadrilateral. If we join the point B to D, are you able to observe the two triangles? The first is our triangle ABD and second is our triangle BCD. By joining the point B to D, that is by forming the diagonal BD, we got two triangles inside this quadrilateral. And we got two triangles and we know all the three coordinates of this triangle. So we can apply our formula of the area of the triangle. Okay, so firstly we will take our triangle ABD. All the values are given, so we will put the value. On solving, we got area of the triangle ABD as 53 square units. Similarly, for the triangle BCD, let's put all the values. We got area of this triangle BCD as 19 square units. Let's add area of both of this triangle to get our area of the quadrilateral, which will be equal to 53 plus 19, that is 72 square units. That is, we got our answer of the area of the quadrilateral ABCD. So what is the learning that we got from this question? The learning is that if we got any of the polygon and we know all the coordinates of the polygon and we have to find the area of that polygon, then we can divide that polygon into the number of triangles. And by applying our area of the triangle formula, we can find the area of all that triangles. And by adding all these triangles, we can find the area of the complete polygon. So this is the fundamental that we have learned from this question. So students, that's it for the area of the triangle. So thank you very much for being with CREATA classes. Bye for now.